Hello, my name is Ehsan. I'm going to teach about the introduction to computer architecture. In this presentation, I will cover 5 key areas. One, introduction is about the evolution from simple 1 and 0 into modern computing. Two is about evolution of components, how transistors form from more complex systems like logic gates and memory. Three is about basic architecture of the computer. Four is about introduction of instruction set architecture. And five is about current technology and sustainability. Let's start by looking at how computers, which are everywhere in our daily life, the foundation of all computer is based on just two numbers, 1 and 0. These are known as a binary number, and all computer operation based on them. In the beginning, computer is just use of vacuum tubes like this to process informations like transit 1 and 0. And the first programmable computer called ENIAC was built using these vacuum tubes during World War II. It was so enormous and filling entire room. And then in 1947, the first transistor was invented by Bell's lab. This was a big deal. Why? Because the transistors were much smaller, faster, and more reliable than vacuum tubes. This allowed also us to shrink transistor and make the computer more powerful. And fast forward today, we have integrated circuit, which are tiny chips with a million of transistors on them. These chips are what power our modern device like computer and smartphone. And yes, so from the vacuum tubes to the transistor, now integrated circuit, computer have come a long way, but they're still operate using just 1 and 0. Now that we know computer works with 1 and 0, let's see how simple component like transistor evolve into more complex system. First, we start with a transistor, small transistor, which act like switch, on or off. It can representing 1 is on and 0 is off. These transistors are the basic building of the block of all of the digital circuit. When the transistors are combined, they form a digital circuit. This is where we use them as perform the simple logic operation, like turning on the light when two conditions are met. For example, both input are 1 and then the output is 1. That's called AND gate. And also we can build more digital gates like AND, OR, NOT, and so on. Each gate perform different operation on the 1 and 0, just 1 and 0. And these gates are crucial in processing data inside the computer. And with more gates, we can build a more complex system like multiplexer, which select input from many. So from many input, we can get one output based on the selections. And also it's next is a flip-flop circuit, the circuit that can remember. So we can basically save the state. Next step is 1 or 0. It's basically it's foundation of memory in what we have in modern computer. Now, let's take a look at how computer is organized. This is called the basic computer architecture. A computer works by taking input, processing them, and then producing the output. At the heart of the computer, we have just two main components. First is the ALU, or arithmetic logic unit, where all of the calculation and logic operation happen. For example, if a computer needs to add two numbers, then the ALU handles that. And second is the control unit. This is component that manage and direct everything, how information move around the computer, how LU operates, and then how to get the data from memory, and then how to save and then produce the output. Control unit is like a brain that control everything. And another crucial part is the memory. Memory store the data and instruction that computer use. Think it as the computer short-term memory, maybe, which hold the information that need in the current task. So the input go into the computer, and control unit tell the LU how to process the data, and the result either stored in the memory or sent out as the output. This is the basic flow of all of the computer works, from very basic into more advanced like supercomputer. They're just a similar basic architecture. Next, let's talk about how computer can understand and execute the information. This is done through something called the instruction set architecture, or ISA. What is ISA? ISA is the language that the computer brain or the CPU can understand. Think as it is a translator, for example, that turn high-level programming language like C or Python that we usually can do the programming code, like we create the program in Python. Then the Python is translate into the instruction set that CPU can perform and understand. Without the ISA, CPU would not know what to do in the code. How does ISA work? ISA work like a recipe for the CPU. Imagine CPU is the cooking, and then ISA is the recipe book. Just like following the step of bake, for example, bake a cake. The CPU will follow the series of instructions to process the data, and this instruction can be anything, like for example, add to number and of data, or also can store the data from memory or fetch the data from the memory, and also can do the checking, make a decision based on the data. So put it simple, the instruction tell the CPU exactly what the step to take to perform the task, just like recipe tell a chef how to cook a dish. The ISA provide the CPU with this information, getting on it or what to do. Basically, ISA is just a combination of 0, 1, 0, 1, 0 that form the instruction itself. So finally, as we move to the modern computing, one of the most exciting advancements is how small and powerful technology has become. On the graph, we can see the evolution of transistor size over the years. In 1987, transistors were about 3 micrometer in size, but now we are in like 3 nanometers technology. The shrinking of transistor means that today computers are much smaller, faster, and use less power than ever before. An example of the 3 nanometer chips is the latest Apple chip that used in the iPhone. This is the cutting edge technology in current technology. These chips are incredibly efficient and play a big role in modern smartphone, like in the Apple that implement in the iPhone. Also in a larger scale, we have supercomputer, like the one that's shown here is called Dartel, which is the supercomputer that owned by KTH. The supercomputer used for advanced calculation and simulations, like in the field of science engineering. These systems are powerful and also designed for more energy efficient. Why this is important for sustainability? Because technology gets smaller and it consumes less power, so it's will reduce the carbon emission. So that more smaller computer, less energy, and then much sustainable. That's nice. So that's all. Thank you very much for listening my presentation. Thank you. Bye.